Good evening, all. I am Anil Baliga, representative from ICI Mangaluru Center. Today we are all meeting for a common cause, good cause, and we are here to see and listen the great engineer L.R. Manjunatha sir, and this is part of the QCrete webinar series that is number 48. And on behalf of all the members of ICI Mangaluru Center and QCrete Readymix India Private Limited, I warmly welcome the speaker for the day, guest, friend, fraternity member, engineer L.R. Manjunatha to this great evening. Welcome, Manjunatha sir.
Thank you, Anil ji, and also QCrete team members, yes. My old friends and colleagues, friends and old colleagues, Shelly Fernandez and engineer V.R. Kaushika.
Good evening. Thanks, Mr. Anil Baliga sir, for welcoming Dr. Manjunatha sir on behalf of Mangalore chapter of Indian Concrete Institute. On behalf of QCrete Readymix India Private Limited, myself Kaushik, just trying to introduce Dr. L.R. Manjunatha. Actually, Dr. L.R. Manjunatha needs no introduction, as he is almost becoming synonymous to GGBS in at least southern part of India and probably all over India. He is honorary chairman, Indian Concrete Institute of Bangalore, member working group, Bureau of Indian Standards, IS 4926, honorary chair, Technical Society for Development of Composites, member, BAS Technical Committee for Cement Manufacturers Association. He is a civil engineering graduate from UVCE, and he finished MBA in International Institute of Advanced Marketing in 1999, and he also finished PGDFM from IGNO and finished PGDM in Lean Management from Alliance University, Bangalore 2008, and he is also finished postgraduate program from Concrete Technology City and Guilds in London Institute in 2009, and he has finished PhD in Management in Green Building Materials and Sustainability Initiatives from Bharatiya University in August 2018. And he has vast experience in building materials, construction chemicals, ready-mix concrete, and presently working as Vice President, Direct Sales and Sustainability Initiatives in JSW Cement Limited, and leads many sustainability initiatives. And Dr. Manjunath has large research experience of more than 12 years, published several research papers, and he has published, if you are talking about numbers is mind blowing. More than 40 national and international publications, and he has been invited speakers for many conferences, and he is invited faculty in ICMAR and many institutes, and a lot of research paper publications, and he is also a reviewer for many publications. I know Dr. LRM since 1996, and we were also colleagues in our previous Readymix concrete company. More than anything else, Dr. LRM is a very kind-hearted, humble human being, and most importantly, he is always willing to help others. That is his most valuable character, I can say. And we at QCrete Readymix today are honored to have him today on our webinar, Series 48. We welcome you, sir. Thank you. Please, the floor is yours now.
Thank you, Engineer Kaushika ji, for a wonderful introduction. I'm a very humble man. I don't require much of introduction. I'm your man, basically. Okay. A man for the construction industry, supporting all the students and other young budding engineers. Today, The topic is very interesting, as engineer Kaushika was telling, and also our Anil Baliga was telling. And Charlie Fernandez was questioning me like, what was the consumption of GGBS 10 years ago, and what is the consumption of GGBS now? From 40,000 tons, 4 lakh tons per year to 4 million tons per year. So that is the growth of consumption of GGBS in concrete application for a period of 10 years. Why GGBS? Why should we use GGBS? What are the advantages and benefits of GGBS in traditionally driven market, pure OPC cement? I still know, like when I started supplying cement, when I was a cement company to RMC, first RMCs were like Fletcher Challenge, RMC India Group. Purely OPC cement was being used. That too in bag. The bulkers were not available. Nobody heard of using any fly ash or any other mineral additives in the concrete admixtures, in the concrete making. Hardly were making M15 to M30 concrete. Somebody makes M40 grade of concrete. It's a great achievement at that time. But now things have changed. Now we are using a series of mineral admixtures, performance enhancing nano materials, ultrafine materials in the concrete admixtures. We have already migrated from ordinary lignosulfonate based admixture to glinium or like PC based admixtures. The technology is advanced, and we are using a lot of nanomaterials in concrete making. The grade now, recently I was checking, okay, M20 grade was predominantly 70%. Now in Bengaluru, I'm checking the M30 grade. We have already migrated to M30 grade. About 60% of the concrete is M30 grade, or 50% of the grade. So as we increase the gradation of concrete, the usage of concrete, the usage of mineral admixtures play an important role. In Karnataka itself, or Bengaluru itself, we are making M80, M100 grade concretes generally now for many structural applications. So when you go for high grade of concrete, we require high durability, high performance. That can only be possible using mineral admixtures, either fly ash or GGBS. You can maximum use cement only up to 450 kg, pure OPC cement. Beyond that, the code does not permit because it becomes more and more brittle. Rate of hydration will increase. But with mineral adhesives, you can go up to 750 kg based on the grade of concrete. That is the advantage of using the additives in the concrete making. So why I'm just coming into the picture, why using mineral additives or GGBS is going to help the whole world. We can see the growth of population, the trend of global population growth. This is the graph taken. So 9.2 billion population will inhabit this planet if no world war happens by 2050. I'm talking about another 30 years. The population growth is phenomenal. We are adding more and more people on the planet. So it requires housing, infrastructure development, roads, bridges, and also the trend, the movement of population from the rural area to the urban area. The Western developed geographies already 60% of the population are living in the urban environment because of better facilities, education, jobs. Whereas in India, up to now, 40% of the population living in the urban conglomerate is going to be 55% by 2050. So imagining by 2050, the population of India may be 150 crores. So 75 crores of the population will live in the urban environment. That is going to put enormous pressure on the infrastructure. The future, we require energy, we require food, we require more land mass, we require more water, and also we require more construction to give accommodation, to give proper infrastructure. All that can happen only through construction, and where cement and concrete are going to play a major important role. My dear friends, today, when you look at construction alone as an industry, it consumes 40% of the world energy. Imagine energy consumption, we are struggling now. Okay, in terms of fuel, cost of electricity. Okay, and also construction alone contributed to 30% of the greenhouse emissions. The gas emissions compared to steel and cement industry alone contribute about 13%, including cooling, heating, and other things. So 30% of the total emissions happen because of construction activity, which is never stopping. Dust, 10% of the global dust is because of construction, because of mining, construction, cleaning, all those things. So with all that, what's happening finally? Our biodiversity is getting affected. So we're going to have more and more construction, more and more mining, more and more usage of cement and concrete. So we are not going to create a better place for our children, future generations. So how? What are the materials of construction? We have so many materials. We have aluminum, steel, glass, concrete, timber, bricks. Okay. So we require a lot of energy to produce all these materials. Okay. Among all those materials, still concrete remains having the lowest carbon footprint. That's the reason concrete is the second most consumed material on the planet after drinking water. Somebody asked a question, which is the second most consumed material on this planet? It's the concrete what we make to build houses, bridges, metros. Okay. So let us look at the overall global picture in terms of cement production. We have 4.1 billion tons of cement produced in 2019. 4.1 billion tons. Okay. Among those, India and China, they produce maximum cement. China is producing 2,430 million tons. India is producing 320 million tons. And each ton of cement production, OPC cement production, is liberating about 0.9 tons of carbon dioxide. So 1 ton is almost equal to 1 ton of this thing. So it is not eco-friendly activity at all. Currently, we are emitting almost 2.3 billion tons of carbon dioxide just because of cement production. So along with coupled with mining of the limestone and creating scarcity of available land for cultivation. So what's happening because of all that? Creating landfills, tremendous emission of carbon dioxide, shortage of fresh water, because we require a lot of water for processing of cement, the cement mill. And cement water is also used for concrete making. But our construction is not stopping, my dear friends. We are going. The Burj Khalifa was the tallest building at I think 826 meters. Now Kingdom Tower is coming in Saudi Arabia, 1 kilometer. We don't know now what they say. The tallest of the tallest buildings are going to come in Southeast Asia, because there's a huge population explosion and also the migration of people from the rural environment to the urban environment. So what is the approach? We have to make the construction sustainable using sustainable materials, which is going to benefit both the owners, the users, the engineer, contractor. So it's going to benefit the entire stakeholder family. How to design concrete which is more durable and sustainable. So, my dear friends, we have so many materials available. Natural materials, industry byproducts like fly ash, GGBS, and blended cements, limestone powders, aggregate fines. Aggregate fines means nothing but processed recycled aggregates. Then ultrafine material like silica fume, kiln dust, rises ash, ultrafine GGBS, nanomaterials like QCrete, natural pozzolanas. So all these materials are getting utilized in making concrete, which is going to be durable and sustainable and long lasting, reduce the life cycle cost of the buildings. So sustainable concrete should be nothing but use economics. It cannot be very expensive compared to our regular control mix. Sustainable concrete, so I already told you, long life cycle material, reduced maintenance cost, reduced cracks, faster constructions, and also give superior finishes. These are the economics and constructability. We should construct slender structures, thin structures, and also reduce the heat of hydration, reduce shrinkage cracks, reduce material volume. In terms of steel and concrete, go for high grade of concrete, you can reduce the thickness of the columns, reduce the usage of steel. So these are the requirements. So, and also for the contractors, it should benefit faster construction, faster pumpability, lesser time, lesser material, improved placement, optimization overall. So when we want to do all that, every time, every cubic meter concrete we produce, RMC plants want to optimize the cost, increase the performance, increase sustainability, durability parameters. Finally, we are looking at lead. India is the second biggest footprint on carbon, because we have the highest number of green certified buildings in the world, second highest green certified building in the world. We're talking about some 18 million square feet. So coming to the total background of construction, cement. So we need new generation materials. We need to make the usage of sustainable materials, durable materials, and waste products which are available from the industries. The only alternative is sourcing these materials from the nearest sources and making use of them, whether it is SCM or MSAT. So I already told you that cement production is not an eco-friendly activity. We have to cut down because it consumes a lot of limestone. 1 ton cement making consumes 1.5 ton limestone. Consumes coal. Today the coal cost is $350. So for each ton of cement OPC making, additional cost is about 600 rupees per ton. That is an increase from $142 to $350. The coal price has gone up, almost 60% it has gone up. Electricity consumption is more, emissions are also more. So we have to work on this, and India is not lagging behind, my dear friends. India is the third largest emitter of carbon dioxide. China is 27% compared to the global emissions, America 11%, India 6.6%. It is much higher than compared to the European Union. So we have a larger role to play compared to other developed and developing economies. As I told you, the cement production, something which cannot be controlled. If you want to make cement, OPC cement, so decarbonizing the limestone, it's going to emit 520 kg per ton of clinker production. Fuel consumption about 325, and electricity usage about 50 to 60 kg per ton. So all put together, the clinker making, total clinker making is emitting about 930 kg CO2. So with that, we are facing huge problem. Greenhouse gas effect. The temperature is warming, ocean temperature is warming. That's why we are seeing unforeseen rains, heavy rainfall, cloud burst, cyclones, hurricanes. All that is happening. So we have to avoid all that. So coming to the concrete as a material, earlier it was only a mixture of only 4 ingredients: cement, water, aggregates, and sand. Today, become a mixture of admixtures. More than 10 products go into making a single grade of concrete. You can use fibers, you can use GGBS, you can use ultrafine GGBS, ultrafine fly ash, you can use iCrete, new nanomaterial, which is available from the QCrete company. So when we want to make concrete, we desire so many performance of the concrete during the initial stage. It should be workable, it should be easily placeable. Okay, when it hardens, we look at compressive strength. 3 days, 7 days, 28 days compression. Durability performance, looking at sulfate, resistance to sulfate attack, chloride attack, alkali silica reactions, and lesser permeability. These are the things we look into the concrete performance. So, what are the challenges we face when we make the fresh concrete in the initial stage? We want the concrete in the ideal condition to be having lesser cracking, lesser voids. But what we get is generally having more cracks, excess voids, bleeding of the concrete, segregation, and poor interface. When the concrete is set, we want lesser voids. We don't want any honeycombs. But when the concrete is set, we always come across cracks, voids, and it will lead to the entry of aggressive external agencies. What are the external agencies which are going to enter the concrete? First is the moisture, second is the carbon dioxide, chlorides, sulfides. These are all going to enter the concrete, whether it's a coastal concrete, the concrete used for marine structures, concrete used for urban environment, concrete is used for roads, bridges, tunnels. Everywhere we are having these external agencies acting on the concrete, and finally what this will do, they will enter the concrete to the concrete interface and affect the reinforcement, which is going to take care of our tension. Once the reinforcement gradually start corroding, then the expansion of this surface of steel will happen, concrete, and the cracks will develop. So finally, we are going to have a weak structure which is going to collapse after some time. So need of the hour is going for sustainable concretes. So my dear friends, sustainable concretes, how we can make? We can make using many technologies, using optimization of materials, using innovative materials, using recycle and waste management products. So with all that, we can develop sustainable concretes. So after developing sustainable concretes, we need to look at durability is very important. If you develop sustainable concrete which is not durable, then we are failing. We are not able to meet the requirements of structural consultants, but by achieving sustainability, achieving economics, durability achievement is very important. That is only possible using SEMs which are very eco-friendly. So concrete deterioration mechanism, we have both physical and chemical deterioration, acid attacks, seawater, sulfate attack. Already we have discussed on these parameters, alkali aggregate reactions, leaching. These are the various things happening on the concrete. Reinforcement corrosion happens through carbonation and chloride attack. These two agents will attack the reinforcement. So we need a product which can overcome all these difficulties. A product like cement, which can replace up to 70 to 75%, gives enormous saving on cost of your concrete. Saving also very important, because when you use any eco-friendly material, the cost should not go up. That is what we are expecting. And long-term strength should be available at doorstep. If the product is not available, even though it's very good, we cannot make use of this product. And enhances the life and durability of the structures. All these products, all these achievements, how we can get from a single product. There's one product which is energy efficient, because production will emit only 50 to 60 kg per ton of 50 to 60 CO2 per ton of production. It's a recyclable product, it's a byproduct from the steel industry, sustainably sourced, it's having extended life for the structures, and also we can certify the building. What is that product called? It's called GGBS. GGBS is called ground granulated blast furnace slag. How it is coming? Somebody may ask, where is that product? From where it is coming? This product from steel manufacturing. It's a byproduct of steel manufacturing. My dear friends, so when we manufacture blast furnace, steel from the blast furnace, we are going to add flux, the raw materials, to heat the iron ore to 1500 degrees centigrade. We had coke and iron ore and limestone. So limestone, iron ore and coke as a flux heated up to 1500 degrees centigrade. When it's heated up to 1500 degrees centigrade, as shown in the diagram, we get the heavy metal separated, that is iron. We take it out and go for the steel production of various items. So we have got 30% for each and every ton of the raw mix. So we get 700 kg steel and 300 kg molten slag. Okay, that molten slag has to be properly treated and quenched into fine granules by using technology. It's not possible. Just like that, if you allow that to flow, it becomes solid rock. We cannot do anything. So using great latest development of technology, we are making into small granules like sugar type. So this is called slag, or blast furnace slag. The blast furnace slag is ground into fine powder, ranging from 300 to 8,000 meter square per kg. So what slag GGBS we are making is 3,800 centimeters per kg or 380 meters square per kg. But if you finely ground the same GGBS, further we can make ultra fine GGBS that is used for high grades of concrete. So general normal grades of concrete up to M60, we are using this material called GGBS. So this is the diagram, the line diagram, how we had limestone, coal and iron ore together to the blast furnace. So we get iron making and we get blast furnace, that we convert into GGBS, and we also convert into slag sand. Looking at the chemical composition, my dear friends, so this is having a very good chemical composition. As per the IS code requirement, the glass content should be 85% minimum, but what we are making is more than 95%. So looking at the mechanism, how the GGBS is going to help us is like this way. When we make OPC cement, we add water, we're going to get calcium silicate hydrate gel. So what will happen? We are going to get calcium hydroxide and CSH gel. When the same calcium hydroxide, which is a very unstable product, which is like a cholesterol in the concrete. How we have cholesterol? If we have cholesterol, we have to remove the cholesterol. We need to remove the calcium hydroxide as much as possible from the concrete matrix. How that can be done? By GGBS. GGBS having higher calcium oxide content, CaO, up to 40%, it will react both hydraulically and pozzologically, along with calcium hydroxide to convert durable product of CSH gel, additional CSH gel. That is the advantage of this product. So it's going to have double reaction. So double reaction means more strength, more durability, more particle packing. These are all the advantages of using GGBS. So this is the diagram where it shows that pure Portland OPC cement, where you are having non-sealing precipitate of calcium hydroxide. When we use GGBS, the slag will react and creates a beautiful product. Hydration of the product of slag along with water. That is the beauty of the product. So we know nowadays high grades of OPC 53 cements are coming to the RMC plants. Everybody want to copy it. How much strength I am giving after 28 days. That is the challenge everybody is giving to the market. All the cement companies, my strength is more, my strength is more, like that. But how the strength is more? Because C3S is more in the cement. If more C3S, as I told you, we're going to have lesser CSH gel and more calcium hydroxide. C2S gives 82% of CSH gel and 18% calcium hydroxide. So as we go higher grades of cements, you're going to have more calcium hydroxide. So that is very detrimental to the concrete. What I'm telling you, you have to reduce the calcium hydroxide in the concrete matrix. That is only possible by replacing the OPC content partially using GGBS or fly ash. The advantages of GGBS are many. It's an eco-friendly product, high resistance to chlorates and sulfates. I'm repeating once again because advantages are many and should be remembered. Reduction in the heat of hydration, improved ultimate strength in terms of flexural strength, compressive strength, beautiful particle packing due to the higher dispersion of the cement particles, improved resistance to corrosion, and improved water impermeability. These are the many advantages of using GGBS. So always people will compare with fly ash. I will use fly ash, I will not use GGBS. I'm not working against fly ash, but what I'm telling you is that GGBS is superior product compared to fly ash because it's both hydraulic and pozzolanic. The reason behind, look at the chemical composition. We are having 40% calcium oxide compared to OPC clinker 62%, silicon dioxide 35%, whereas cement is having 22%, aluminum oxide 14%, clinker having 5%. So look at the fly ash. Fly ash is only having only 2% calcium oxide. It may be rich in silicon dioxide. So it does not participate immediately with the concrete hydration process. It may take 3 days or 4 days to participate. But since GGBS is having 40% calcium oxide, after 10 hours, when the concrete is set, when we walk on the concrete, should not make any impression. Maybe 10 hours or 12 hours, immediately the GGBS will start reacting so that there is no tremendous drop of strength in the concrete. So those people who are having mindset, if I use GGBS, strength will be less, strength will be reduced. You have to remove from your mindset because this is having calcium oxide. That is the beauty of the product. And also, when you want to use fly ash, this all given by the transporters. They go and load it in a power plant, and if it is not available, they may load pine ash or lesser finer material. There is no MTC given. They don't tell you which source they are getting the material. There is no bill. All that issues are there with the fly ash. But it's a product people are using. When GGBS, it comes with a manufacturer MTC. So it's just like cement. It gets all certification. It's having green certification. So you can close your eyes and use the product. Otherwise, every time when you get a fly ash truck, you have to check for fineness, residue, all those things are there. Consistency is always there with the GGBS, but that is not there with fly ash. And replacement levels, you can replace up to 35% maximum with fly ash. The quality is very good. But generally, people are going with 30%. Whereas, in the other hand, if you are using GGBS, you can go up to 70%. There are instances people have used up to 85% for many applications. In our own, in Karnataka, Carver Seabird project, where they are doing piling, Larsen and Toubro, they are going up to 70% for grade of M55. So that is amazing. So because they have found the benefit of using the product in terms of performance, mainly durability. So consumption area and applications. So GGBS is going in Readymix concrete, captive plants projects, is going to asbestos sheet manufacturing, hollow blocks, is going to tile adhesives, is going to tile grouts. Many applications it has found, going for soil stabilization also. It's a versatile material. People are making some white cement, bit whitish in nature. So using white cement, they're replacing white cement for tile adhesive application, for color concreting applications, GGBS, because it can replace white cement, which is quite expensive. per kg maybe 10 to 15 rupees. So this comes at an average of 4 rupees per kg. So this is a very good replacement where you want decorative products. Many studies have been done at various laboratories. IT study is one such study where we have done GGBS mixes. You can see the graphical representation how the strength improvement is happening with various percentage starting from 100% OPC, 60 OPC, 40 GGBS, 50-50, and 40 OPC, 60 GGBS, 30 OPC, 70 GGBS. With that combination, I will just see how the strengths are growing. Earlier, the OPC strengths are better, but gradually, when you look at the overall compressive strength for 56 days, 90 days, the GGBS, the higher replacement has performed much superior to the ordinary Portland cement-based concrete. You see, with the 40% replacement of GGBS, 95 MPa, with 50%, 83 MPa, 80 MPa with 60%. That's how the advantages are many. So looking at the water absorptions, you can see the results at 56 days, the higher replacement is coming down gradually. Similar way, structural strength also we have seen 28 days, 56 days, giving a good, better performance the higher replacement. So we have seen optimum 50 to 60% we are getting the results. Similar way, carbonation depth gets reduced with higher replacement levels compared to the OPC mixes. Migration tests. I'm going to share the PPT to all of you. Similar way, looking at the mixed proportions at metro projects where we have done various mixes, M35 grade with 50% replacement, you see a gradual jump in the strength, 56 days compared to 28 days, almost 10 MPa more strength in the pile mix. Similarly, M60 grade concrete is given better performance. That's why I want to call GGBS the most sustainable material on this planet, because bringing down the CO2 emissions enormously. Because GGBS, you are adding, let us say, each and every ton of OPC cement just emitting 930 kg CO2. GGBS, the production of GGBS only 60 kg per ton. So net of, if you mix 50%, so net emissions will be okay. For every ton of GGBS, you are going to save 870 kg CO2, 870 kg. Let us say, if you are using 10,000 tons of GGBS in the concrete, you are saving 10,000 trees, because each tree will absorb 1 ton of carbon dioxide in its lifetime. So sustainability is very important, because sustainable comes with social benefit to the end users, economic benefit to the contractors and the client, environmental benefit, reducing the carbon footprint. This all can be achieved by using supplementary cementitious materials. So I'm going to talk about many case studies with this. The advantage of mixed design, you may always feel, okay, you have to add more admixtures. It is not so. The same combination of admixtures, transportation time is same, concrete manufacturing time is same. So there is no change at all. Just it is replacing the OPC content in the concrete. And also using GGBS, since it is finer than cement, so your admixture dosage will come down. I think Dr. Engineer Kaushika will watch for that. I'm generally have found at least 0.1% admixture dosage coming down when they use GGBS, because many admixture companies, any new project is coming, so they always come to us, sir, there is a scope for using GGBS, kindly come with us. We're laughing at them. Why you are promoting our products? If you use your product, my dosage will come down so that I can give a better rate to the end users, the consumers, the contractors. So benefits are many. Engineering benefits up to 30%, usage benefit up to 85%. So 50% replacements are general, where commercial ready-mix concretes are there. Wherever it is specified, people have gone up to 30 to 70%. So people have to remove that from their mindset. Okay, my shuttering time will get distorted. No adjustments striking time. You can demold the buildings, de-shutter the buildings, same time what you're doing with OPC cement. Because this is a hydraulic material. Pressing compaction, power floating, everything goes smooth, compatible with admixtures. That's a beauty because we are able to sell 4 million tons per year. Otherwise, it would have been much difficult. So various replacements levels are there for applications, and based on the requirement, whether you are doing a mass concreting application, go up to 60%, column structures go up with 35 to 40%. Then based on the grade of concrete, it is a my one formwork where M30 grade of concrete is generally used smart dynamic concrete, go with 50% replacements. So based on the applications, we can vary the content. That is the beauty of mixing GGBS at the RMC plant. When you use a blended cement, either slag cement or PPC cement, that advantage is not going to come to you. You can start from 25% to 70%. We can blend based on the grades of concrete, based on the distance, based on the requirements, specifications. We can make a tailor make how you had salt, food, or you had anything, sugar, how much sugar you are going to add. So like this is an additive where you can change the proportions based on your taste, based on your requirement, based on your specifications. So working with GGBS makes you happy. The particle sizes of GGBS are much smaller than cement. So wherever the interfacial transition zone, there's a gap between two cement particle, the GGBS particle will go so that it will make the particle packing effect more dense, so that voids are avoided. That is the beauty of the product. So these are many the pictorial representations how GGBS is going to improve the performance of concrete. Not going to spend much time on this. So there are several case studies. I would like to go one by one. Don't want to spend much time on this. So, but all case studies show the performance of GGBS. So when the specifications are more than 120 years, the service life is very important, especially for marine structures and metros and elevated corridors, where we go with higher replacement of GGBS. This is performed very well in Mumbai Metro. Look at the RCPT value, just come down, 703. Physical properties and non properties. So many case studies we have done. Tricon RMC in Pune, we have done a comparison between fly ash mix and GGBS mix with various grades starting from M20 to M50 grade. The GGBS mixes performed much better than the fly ash mixes. That is the beauty of the product, is much above. So many examples are there. Already discussed with you the advantages. This is one more mixed design where we have used 130 cement and 190 GGBS for an M25 grade of concrete. We can see various series of trials. When I was in RMC India, Bengaluru, we have done these mixes. Even Kaushika is aware, also Mr. Shelly Fernandez is aware. So M25 grade concrete, 28 days compressive strength, average is coming to about 32, 33 MPa. But when you look at the 90 days compressive strength, almost coming to 45 MPa. That is the beauty, the gain of compressive strength for a period of time with the higher replacement of GGBS. Similarly, the durability performance is very good. RCPT value with a higher replacement 50% coming to below between 600 to 500. All the parameters. Splitting tensile strength improvement is there. Flexural strength improvement is there compared to the durability performance compared to the pure OPC mixes. So all these things have been studied at various laboratories, not only at research laboratories, but practical applications like RMC plants, QCrete or RMC Readymix India. Many companies like Ultratech, many people have studied the product and continuously using this product for various applications. This is one more application where the entire building, Shobha Indraprastha project, now which is housing the one of the largest shopping mall, global city mall in Bengaluru, which was built using monolithic construction, using my one formwork. The entire structure was done with 50% replacement of GGBS for M25 grade of concrete. You see the performance. Well, we studied the strength up to 181 days. So you can see the M25 grade concrete giving 55 MPa, almost double the strength of its original grade M25 over 183 days. So to make it believe, we have taken the screenshot when the details were maintained at their laboratory at site. So this is a handwritten document. So we have not fudged any numbers here. So M25 grade concrete becoming M54 grade. Various applications. So not only in concrete applications, the GGBS is being used for block manufacturing. So we have done various study and performance parameters. Sorry, tested on bulk density, drying shrinkage. Each block we can save almost 2 rupees. And a company making 10,000 blocks per day can save 1.96 crores per annum. The advantages in blocks: enhanced long-term strength, better finish, reduced breakages, cost saving 1 to 3 rupees per unit. It's a green sustainable product. Similar way, we tried with door frames. We've done with paver blocks. All the applications we have tried out. The precast slabs, everywhere. So it's not that only suitable for concrete, any applications. So coming to the durability, I've already discussed in length the durability parameters. With higher percentage of GGBS, the fluoride penetration coming to almost 0. Similar way, sulfate resistance is getting minimized at 50% replacement compared to the OPC mixes. Heat of hydration, especially using more than 60% GGBS. If you are having a raft more than 1.5 meters to 2 meters, will substantially going to reduce the heat of hydration, which is very good for mass concreting applications. Aesthetical properties, architectural qualities, it gives very lighter appearance. So especially when you use for PQC or concrete roads, the visibility is much more superior during night time. If you don't have street lights, the road will be visible properly. Nice road, they are using GGBS. You can see if you want to ride on the nice road in the evening time, you can see the concrete surface very light. And also, it's a product of the future because of the various advantages: lesser cracking, light color products, very good architectural appearance, and albedo benefit because it does not absorb more sunlight. It emits it back so that the surface don't get overheated. So the earth's temperature does not go up. If you are making all the roads with concrete roads with higher replacement of GGBS in the PQC, definitely the absorption of heat won't happen. So the surrounding area will be much cooler compared to the bituminous road concrete. urban heat island effect can be avoided by using GGBS in concrete roads and other open structures, because entire roads in Bangalore or any city we are covering with concrete roads. Bangalore or Mangaluru, we are using only concrete road. So if concrete road is the future in urban environment, GGBS is the best solution to reduce the urban heat island effect. So already I've discussed on these points. Clearly, this product stands superior compared to any other mineral additive, because it's a manufactured product, come from reputed industries. Best benefits. These are all the summary of using GGBS. And also environmental impact assessment, if you take looking at the climate change effect, how much compared to the cement, OPC cement, how much reduction is there? You can have a look at it. Overall energy efficiency, mineral extractions, waste disposal, all these points, GGBS is class above ordinary OPC cement or fly ash. So look at the greenhouse gas emission per ton of concrete. These are the numbers which have been calculated. This clearly shows the GGBS concretes are superior compared to the pure OPC concretes, or even superior to the fly ash mixes. So with an higher replacement of M7, 70%, the M30 grade concrete, how much CO2 reduction you can do? It is shown here. I've done a small calculation by using 40% replacement for a 350 mix of concrete, GGBS, how we can reduce the carbon footprint. For every cubic meter of concrete, 105 kg CO2 emissions is getting reduced. So based on that calculation, we have done a thing. If you are, the basis is that one tree can absorb 22 kg CO2 per year. So in its lifetime, it's going to absorb only 1 ton of carbon dioxide. So that means to say, if I make concrete with 40% replacement of GGBS, it can reduce 105 kg per cubic meter of concrete. I've done a calculation for 10,000 cubic meter of concrete. So it is equivalent to planting 1,050 trees, because to absorb the carbon dioxide, we have to plant trees. So by using GGBS, I'm not telling that you should not plant the trees. Equivalent. We may not be able to plant trees everywhere, because Bangalore we are cutting trees for road works, for metro works. Talking about 5,000 trees. Now they were announced the peripheral ring road, talking about cutting down more than 1 lakh trees. So if you can use GGBS, the same road in your constructing, we are making 2 lakh cubic meter. It's equivalent to saving 21,000 trees. So making 5 lakh cubic meter equivalent to 50,000 trees. This is what we can achieve success. So major infrastructure projects which have recommended GGBS everywhere. Mumbai, Metro Rail, MSRDC, Konkan Railways, Trans-Harbour Sea Link, they've all used GGBS for their applications. Nagpur Metro, Bangalore Metro, CPWD, PWD. So major infrastructure project, Atomic Energy Regulatory Body, National Highway Authority, CIDCO, they have done replacement up to 50%, up to 70%. So Mr. Shelley Fernandez was asking me, there is a code for GGBS. Yes, it is there. GGBS code IS 16714 2018. You can refer, you can download from the internet. That code says how the GGBS is manufactured, specification, gradation, fineness, everything is there in that code. So codal provisions, almost in all the codes, the mention of GGBS is a SEM, it is there. Concrete mix proportion latest code as a guideline on mixing of the GGBS. IRC codes, IRC 15 2017 approves the usage of GGBS up to 50% for PQC, pavement quality concrete. So many projects we have: Mumbai Port Trust, Chennai Metro, Bangalore Metro. Already I discussed it with you. Major clients, you name any infra company, they are using GGBS. These are the examples. Government approvals. Then major infra companies like Tata Projects, Afghans, Dilip Buildcon, Nagarjuna, J. Kumar, Soma, Shirke, Mega Engineering. They consume lakhs of tons of GGBS every year. Commercial RMC plants also: QCrete, Architect, Novaco, Prism Johnson, ACC. Name few. Almost all the RMC plants in Bangalore, Karnataka, they're using GGBS as a primary replacement for OPC cement. Residential groups, many builders like Prestige, Brigade, Shobha, Aparna, Niranandani, they are using GGBS, Sapurji Palonji. So we have done a small calculation of the GGBS, how it has benefited the whole world. This is the usage for the last 5 years. We've done a calculation. So it has reduced almost 5.24 million tons of carbon dioxide, conserved limestone up to 8.36 million tons, and saved land mass of 10.37 million tons. So this is, I'm coming to the end of the presentation. We have also done 3D printing. We have sent JSW Group as tied up with IIT Guwahati for R&D work on 3D printing. We have sent the GGBS and slag sand, one more additive, byproduct of slag. These are the students who are working on this project, PhD students. They are sitting, they have printed this table and chair using GGBS mixes. So with all that, I would like to talk about my company at the last, JSW. This is the largest eco-friendly cement company, the #1 eco-friendly cement company in the world. There are so many big companies like Cimex, Holder Bank, Ultratech, Volsim, many companies. They are global leaders. But JSW is the first #1 cement company. Our carbon footprint average is 248 kg per every ton of cementitious material, OPC or slag cement or blended cements or GGBS. Our carbon footprint is the lowest in the world, with having 248 kg an average. So with that, I would like to conclude my presentation. It's a material of choice. GGBS helps to rebuild the whole ecosystem with sustainability, growth, development. It is being used not today. It's being used more than 75 years or 100 years. It's tested globally. Many countries have adopted using up to 80% GGBS in the mixes. With that, I would like to conclude with my concluding note that we have a great future ahead. Using these wonderful products available in plenty, you may say that how much is available. Currently, India is producing about 40 million tons of GGBS, which is slag. From we have a steel production of 130 million tons. By 2030, the steel production is going to go up to 300 to 320 million tons. With that, we are going to have about minimum 100 million tons slag. So that is equivalent to almost, if it is going to use up to 70%, where we use fly ash up to 25%, 3 times the usage of fly ash. So if fly ash is diminishing because government is closing down the thermal plants, they are moving to renewable energy, going to wind energy, solar energy. But GGBS is coming because steel production is going to go up substantially because we need more and more steel for infrastructure. So with that, we are going to get more and more slag, more and more GGBS. So it is going to be the product of the future. Availability will be enhanced throughout the country where our steel plants are there. With that, I would like to conclude my presentation today. I thank Indian Concrete Institute, Mangaluru Center, QCrete India for providing this wonderful opportunity to share my limited knowledge on this subject. I would like to tell all the viewers who are about 174 people that this product is very good. It is quality product and it's going to make the construction durable, sustainable and long lasting. I request all the attendees to start using this product because it is very eco-friendly, reducing carbon footprint, making the world a better place to live for all of us, for our children, our grandchildren, and the future generations to come in the next century. Thank you all for providing this opportunity. I hand over the floor to the organizers now. Thank you. Anjali? Any questions? I'm open.
Thank you so much, sir. Sir, we have a few questions.
Yeah. Any word from Kaushika?
Sir, thanks a lot. Wonderful lecture. Now we'll move on to question answer session. Yeah.
Want to make a summary? You can make it. Later we can take the.
Sir,
I'm proud to say that Kaushika was the first person who started testing GGBS for concrete application in RMC plants. He can share his own experience, how it is beneficial to the concrete industry.
Thanks, Dr. L.R. Manjunath, for this wonderful lecture. And once again, as I said, QCrete Readymix, we are thankful to you. The most important thing is, if you consider Bangalore market itself until 2007, 2008, our experience is predominantly fly ash market, and from 2007-8 onwards, there is a quick progression in usage of GGBS, not only in Bangalore market, in all over India, wherever the GGBS is easily available. As you have summarized, the product is really has done wonders in terms of increasing the durability, contributing to sustainability, and in the reduction of carbon dioxide emissions. And probably, as you said very aptly, we have been taken to next level of sustainable products by using this wonderful product GGBS, and I hope we try to use more and more in all forms of concretes wherever possible, and we are going to make this planet better by using this product. Thanks a lot.
Thank you, sir. Thank you for the summary. Anjali madam, any questions?
Yes, sir. So the first question is, in some cases, surfaces looks like green color while using GGBS, and how to eliminate this?
Yeah, because of the this thing, it comes in a green color. Okay, so after some time it vanishes. The green color will vanishes for some time. Even if you use slag cement also, the green color will be there for some time. That will vanish away after maybe 2 weeks or 3 weeks.
Oh, okay. Thank you, sir. Sir, the next question is asked by Mr. Shivashankar TV, and the question is, why PSC is not getting strength in higher grade of M50 and above?
It depends on like what kind of percentage of GGBS is being used in the PSC cement. Okay, so strength how we can get is that, like, you have to increase the cement content. Higher grade of concrete requires higher clinker factor also. Higher grade of concrete we try to use about 35 to 40% maximum. If you're using because I'm giving an example of higher grade of concrete where they're using in L&T Carvas seabird. They are using 70%. They are getting strength, whatever strength required with even 60 to 70% of GGBS they are getting. So PSC also, by using ultrafine material like QCrete or ultrafine GGBS, ultrafine fly ash, by tweaking 3 to 5%, we can achieve that strength parameter. We need to add ultrafine material, want to improve the strength of the concrete with using PSC cement. So mixtures can be done using PSC. There is no problem at all.
Okay, thank you so much, sir. The next question is, are there any criteria like purity to be checked for usage in concrete?
I didn't get that question.
Sir, is there any criteria like purity to be checked in GGBS while it is being used in concrete?
Yeah, when the GGBS arrives, it comes with a well-known product group like company, and the product is sealed and all. You have to take the sample and do the 45 micron sieve analysis, wet sieve analysis and all, check for the retention. And there are so many parameters, the fineness test, slag activity index. So the IS 16714 give all the guidelines. So you can check it, and you can ask the manufacturers to give the MTC, just like cement. So you can conduct the test and ascertain the quality and start using.
Thank you so much, sir. The next question is asked by Niveta B, and the question is, are there any specific code for evaluating the fresh mechanical and durability properties of GGBS incorporated concrete?
Yeah. See, for durability, we have got many tests like penetration test. Then we have got RCPT test. Many tests are being conducted. So you can use all those tests just to check the suitability of the GGBS for concrete.
Thank you, sir. The next question is, while using GGBS in concrete, stripping of vertical elements, if delayed by next 24 hours, is there any impact on the concrete?
No, generally you are designing the grade of concrete for stripping purpose. By using GGBS, like now people are making U-trough for Bangalore Metro. So it's not the GGBS only will affect the your stripping time or this thing. How you are designing the concrete mixes, how you want to attain the strength. Somebody say I want 18 MPa strength in 12 hours time. People are designing that. They use 30% GGBS. So the stripping time, the strength requirement, it all depends on the grade of concrete, how you are designing the mixes. I'm seeing all the precast industry now, Shobha, then Brigade, the Sapurjipology, they've all used GGBS for precast elements, and also even the metro for the segmental elements, they're using GGBS. They use a 25%, 30%. So you have to design the mixes accordingly. That's what is the criteria.
Thank you so much, sir. The next question is, what is the maximum recommended percentage of GGBS to be used in M60 grade concrete? And that was asked by Mr. Rajkumar R.
Okay. See, starting from GGBS usage starting from 25% to 85%. Okay. It depends on what is the cement content, cementitious content, what is the durability parameters. Mainly, let us say you only require strength, M60 grade concrete. I think that with 35 to 40%, you can use it. But somebody says, my RCPT value should be low, my water absorption should be low, water penetration should be low. With these are the conditions. So strength becomes the second criteria, but we can specify 56-day strength for M60 grade concrete, not 28 days. But you look at the strength, then you have to go with iron replacement. So when you want durability, it demands iron replacement of GGBS. When you only require strength, then you have to go with a lesser replacement of GGBS. So GGBS will help you to achieve your durability criteria, sustainability criteria. Somebody will limit. In this concrete, I only want 90 kg CO2 emissions per cubic meter, 100 kg. That is going to come because I am working with global cement and concrete associations. We are working on by 2030 how to reduce the carbon footprint in concrete manufacturing. All over the world, yesterday we discussed with all major cement companies globally, Holcim, Heidelberg, Lafarge, and Cimex. So they were all working on like we should specify the concrete based on the CO2 emissions reductions. When that comes into picture, then the usage of GGBS will increase in those grades of concrete. The usage of pure OPC concrete will gradually come down.
Okay, thank you, sir. Next, we have a question by Gunashekar S, and the question is, why do we select M20 or M30 grade of concrete as the control mix?
Yeah. So this will be the last question I'll answer. Balance question, you can send it to me because I also have come for a function, the birthday function of my colleague son. So they should not get over. It's about I could squeeze in time both the things. So the grade of concrete is based on your structural criteria. The requirement of your to hold the bending moment and shear force and other things. So the structural designers design the concrete mixes based on its requirement to take the loads and moments. So M20, M30 grade concrete based on the span, based on the thickness of the slab, based on the load coming on the structures. That's how we decide the grades of the concrete.
Okay, thank you so much, sir.
Thank you. Balance question I will take later on. So I request Shelly Fernandez also to say a few words about overall.
I'm coming on screen actually. My job to give out of thanks. Thank you very much, Dr. L.R. Manjunatha, for giving us a wonderful lecture and a good insight into the why we should use GGBS in concrete. As I told you earlier, this is given a direct reference to all the participants, directly asking why we should not use GGBS in concrete. And you are now becoming synonymous with GGBS now. So as soon as somebody says GGBS means Dr. L.R. Manjunatha, it comes into picture actually. So, so you have made it more popular, and that's why I asked a question: how much increase has happened in last 10 years? You started your propagation.
Now it is coming to almost 4 million tons per year. I am projecting it will become 10 million tons in next 5-6 years time.
Yeah. So that's a dream run actually, and hopefully I think right now you are based in Bellary, but most of the coastal areas are not being covered actually. That is one concern. Like it becomes costly when it comes to the coastal areas like Kerala or right up to Trivandrum. What happens is that this particular one material, which I feel is very good both for coastal environment, because it will resist both the chlorides as well as the sulfates actually. This one particular material, and if it is used judicially, is one of the excellent material for all the coastal constructions actually. Right now we face a lot of structure deteriorations because of the chloride or might be sulfate attacks actually. So these two can be resisted by using effectively by using GGBS actually. Here in coastal area we cannot go for sulfate resistant cement. If we go for sulfate resistant cement, what happens is chlorides enter the structure and it damages actually. So the best material from my point of view is GGBS for the coastal environment. So I request or humbly tell that you have to have some facilities where you can supply GGBS right in all across coastal areas, and because India is having a lot of coastal belt actually. So the entire coastal belt should adopt this GGBS actually, a very fine material for durability of the concrete structure actually. So thank you very much.
No, I want to clarify, support you. We are our plant is getting in inaugurated on 30th of this month at Salem.
Okay.
50,000 tons per month. So that will cater to the entire coastal belt of Kerala and Tamil Nadu. Okay.
Okay.
So we have a plant in Dolvi that is catering to the requirement of Gujarat and Maharashtra. So we have a plant in Bellary which is covering the Mangaluru coastal area. So entire south is covered, but we are making slag cement in the Jajpur area, where Orissa. So we have completely covered the completely coastal area. Vizag, not we are other companies are manufacturing GGBS. So there is no shortage of GGBS along the coastline, according to me. It's available, and also
right now the cost is little higher actually when it compare logistic cost, because the transport cost is little higher when it starts from Bellary. So that has to be taken care for more and more usage of slag in the coastal area. I require 100% concrete should be replaced with slag concrete actually, instead of
that is correct. That is being done with our Salem plant, which is our getting operational from this month end.
Okay. So thank you very much, Ella, for giving a wonderful lecture and giving an insight into why we should use GGBS in concrete. Thanks a lot for coming to for our QCrete webinar series actually platform and delivering this lecture actually. Thanks a lot, sir.
And thank you, sir.
I thank Indian Concrete Institute Mangaluru Center and particularly Anil Baliga for associating with QCrete for successful conduct of QCrete webinar series actually. And I hope many more webinars will be again planned with different topics and with different speakers will be coming to our platform to deliver a series of lectures which will definitely benefit our participants actually. I thank VR Kaushika, Director QCrete, and Anjali, Techno Marketing Officer Techno Marketing, for coordinating and successfully conducting these webinars actually. And I also thank the most important all the participants for giving us more and more encouragement to come up with new topics actually. Thanks a lot to all the participants for attending this QCrete webinar series actually. I'm Shelly Fernandez, Managing Director for QCrete Readymix India Private Limited, signing off from this webinar, only to come back with a new topic next within another few days actually. Thank you very much.
Thank you, sir. I will leave the webinar. Thank you.
Thanks, sir. Baliga.
Hello. Yes, sir.